Hello, 8th grade math students. Mr. Lawrence here, and I'm putting together a couple little videos to help you prepare for this Unit 1 test. This won't be everything on it, but it's stuff that you can review. All right, first of all, here is the number system. It's just like the game we play in class. I need you to be able to name all of the number systems that a given number is a member of. Okay? I would love for you to pause the video, try this on your own, do it in your notebook, and then go ahead and unpause the video and you can see my solutions. All right, here we go. If you haven't paused the video yet, go ahead and answer all 6 questions. All right, number one. Let's see. It's not a natural number. No, it's not a whole number. Is it an integer? Some of you think so, but it's not. Integers do not include do not include fractions. They do include some negatives, but not all the negatives, only the negative of the whole numbers. So it is not an integer. It is a fraction, which forces it to be a rational number. And of course, every number we deal with in here is a real number. Every now and then I will mention a non-real number, but the ones we deal with are real. Number 2, the square root of 12. I'll bet you don't know the square root of 12 if you've been paying attention in class. We've estimated the square root of 12 before, but the square root of 12 is not a perfect square. Taking the square root of it will give me a number like pi, where it's a decimal that goes forever without repeating. That forces it to be irrational. And of course, it is also real. Irrational and real. You don't have to use the symbols. You may use the words, remember. All right, number 3, I've got this 1 and 23/100 ... Remember, the ... means the number is like pi, forcing it to be irrational and real. It's a decimal that goes forever without repeating. Okay, number 4, I've got 26ths. All right, I can simplify that to 10/3 if I want to. Yeah, if I divide them both by 2, let me see here, let me get a marker out here, and if I divide both the numerator and the denominator by 2, I'm going to get 10/3. If you want to go mixed number, you can. You don't have to. That'd be 3 1/3. If you need help on doing that, come see me. Okay, this is a fraction. Any way you look at it, all fractions are automatically rational and real. Okay, there are no fractions in the natural, whole, or integers. -35. It's not a natural number. It's not a whole. Natural numbers begin with 1, 2, 3, etc., right? Natural numbers go 1, 2, 3, on forever. No fractions, no decimals. No 0, no negatives. Whole numbers are 0, 1, 2, 3, on forever. Just like the naturals, only they also include 0. All right, so 5. -35. Is it an integer? Well, is 35 a whole number? Sure it is. This is the negative of a whole number. That's the definition of integers, the whole numbers and their negatives, forcing it to be rational, and then therefore it is real, right? Finally, 0, that's one you're pretty good at. It's where the whole numbers start, then the integers, rationals, and reals. All right, very good, very good. Okay, here we go. Rational or irrational? Again, I want you to pause the video and then decide where these belong. Go ahead and write them in your notebook. Write rational, irrational, and put them where you think they go. If you haven't paused the video and tried this, please do so now. Here are my solutions. Square root of 10. I don't know the square root of 10. It's a decimal that goes forever without repeating. There is no actual square root of 10. Irrational. The negative of the square root of 25. Well, the square root of 25 is 5. It's a perfect square. The negative of that would be -5. That's a rational number. -5 terminates. It doesn't go on forever without repeating. All right, 3 6/10. 3 6/10. Let's see, it's a decimal. Does the decimal terminate or repeat? If so, it's got to be rational. If it goes forever without repeating, it's irrational. I've only said that like 8,000 times. It's a decimal that terminates. 3 6/10. Bam, there it is. All right, 3 6/10 ... Well, in the last part of the video, we mentioned ... means it goes forever without repeating. This will be irrational. All right. Oop, there's another number hiding down there. Feel free to pause the video and decide on that one. Pi. You should all know that pi is irrational. Yes, it is. 3 and 1400. It's pi. No, it's not. It's a decimal that terminates. Too many people think this is pi. No, it's a rounded version of pi. Pi goes forever without repeating. Ever and ever and ever and ever. Okay. 5 and 1700ths, and it looks like the 17 is repeating. Repeating decimals are all rational. And there you go. All right. Estimating square roots. Again, pause the video. You know what? I think I'm going to do the square root of 40 for you. I'm going to do that one for you, and then you can pause the video. So I'm going to sandwich square root of 40 between its perfect squares, right? I'm going to write down some perfect squares off to the side here. Well, my marker keeps moving on me. 1, 4, 9, 16, 25, 36, and 49. Why am I stopping at 49? Because 49 is the first number after 40. So I know that the square root of 40 is going to be between the square root of 36, which of course is 6, and the square root of 49, which of course is 7. So the square root of 40 has to be 6 something, somewhere between 6 and 7. So the square root of 40 is closer to the square root of 36 than it is to 49. All right, now I'm going to estimate. I know my whole number is going to be 6. I'm going to get 6 in some fraction. How far apart are these numbers? Well, they're 4 apart. How far apart are these numbers? They're 13 apart. So that means a good estimation of the square root of 40 would be 4/13. Now, to get the decimal to the nearest tenth, I'm going to have to do some long division. So I'm going to do 4 divided by 13. Now, 13 does not go into 4. I need a decimal point, and I can put a 0, right? And so how many times does 13 go into 40? Well, let's see. 13, 26, 39. There we go. It's going in 3 times. Remember, I've showed you this trick where you can count by the number out here until you figure out how many times it goes into the number inside the division box. Now, you don't have to multiply because you already know that 3 times 13 is 39. You just figured it out over here. So that's 39. I'm going to subtract, and that is going to get me 1, and then I bring down a 0. Now, 13 does not go into 10, so I'll put a 0 here. Now, if I was doing the whole problem, then I could continue to divide. But since I said the nearest tenth, I'm able to round. I had 6 and 4/13, which is about the same as 6 and 30/100ths. And if I round that to the nearest tenth, I can say that the square root of 40 is approximately 6 and 3/10. And that is a close enough estimation. All right, I'd love for you to pause the video and go ahead and do 2, 3, and 4. All right. If you haven't paused the video yet, do so now. Here comes my solution. All right, let me think here. So 21 is going to be between 16 and 25. I'm thinking it's just a wee bit more than halfway. Square root of 16 is 4. Square root of 25 is 5. Let's see, this distance is 5. This distance is 9. Yeah, it looks like a good mixed number would be 4. Take this number, right, the square root of 16, and 5/9. Okay, when you do the long division on that, you're going to end up with a repeating decimal of 4, 5 repeating. So to round that, you're going to say the square root of 21 is approximately 4 6/10. That is a very good estimation. Okay, square root of 85, that's going to be between the square root of 81 and the square root of 100. Okay, well, I know this is 9, and I know that's 10, so an estimation for the square root of 85 is going to be 9 something, right? All right, so let's get the fraction. So that's 4, 81 to 85. 81 to 100 is 19, so that's going to be 4/19. All right, let's do our long division. 19's going into 4. Okay, I'm going to count by 19s off to the side here. 19, 38. Oop, there it is. It goes twice. That'll be 38. I'll subtract and get a 2. Bring down a 0. Get 20. It's going in 1. Okay, so it's going to be about 9 and 21/100ths, rounded to the nearest tenth, would make it 9 and 2/10. And there's a good estimation. All right, finally, the square root of 32. It's going to be between the square root of 25 and the square root of 36. Okay, so it's going to be 5 something. That's 6. This is 7. This distance is 11. So I'm going to get 5 and 7/11. So I'm going to divide 11 into 7. All right, that's going to go 6 times. Going to subtract. Going to get 4. And it looks like it's going to go 3 times to give me 33. Yep, that's correct. So now I can say that the square root of 32 is approximately 5 and 6/10. And there you go. There's your video, ladies and gentlemen. Just a little refresher to help you get ready for Friday's test. Okay, if you need more practice with this, come see me, Mr. Lawrence. Signing off. I can't remember how to end the video. Oh dear, what do I do? All right, I will see you later if I can ever end this video.